So today let's examine a two-period American call option put option using a binomial option pricing model. Let's take some assumptions quickly. The current stock price is 50 and the strike price is 52. Option expires in 2 years. The number of steps is 2. So the discrete time is 1 year, 1 year. The risk-free rate of interest, let's take 5%, continuous compounding. The upward movement, the stock moves by 20%, moves down by 20%. So these are all the inputs given for the model. So let's quickly calculate the U and D, the up factor and the down factor. So 1 plus 20% is 1.2 and the down factor 1 minus 20% is 0.8. So the second step is to calculate the up probability, that is nothing but exponential RT minus D divided by U minus D. And then the down probability is a 1 minus the up probability. Let's keep the discounting factor ready, exponential minus R into T. Now let's quickly go into and how to calculate an American call option using a two-period binomial. And the 50 is a current stock price, so it can go into 50 into 1.2 or 50, it can come down to 50 into 0.8. Similarly 60 into 1.2 and 60 into 0.8 or 40 into 1.2 or 40 into 0.8. The middle node is a repetitive. So once you calculate the node value, you have to calculate what is the payoff value. Since it's a call option, the payoff value is maximum of and 72 minus the strike price 52, that is 20. So maximum of, and 48 minus 52 is 0. Maximum of 32 minus 52 is 0. So these two options, you can see there is no intrinsic value since the node value is less than the strike price. Now, so once you have calculated this thing, then you have to approach the same way how we have done in the European option pricing model. Calculate the expected value 20 into the upside probability plus 0 into the downside probability multiplied by discounting. Why do you multiply by discounting? Because since we are moving backwards. Okay. Similarly, 0 into upside probability plus 0 into the downside probability into the discounting is 0. Now, here since it's an American, this is the only difference here. We have to examine whether it has got an intrinsic value or not. So let's look into it for a call option. Maximum of 60 minus 52 is 8. Similarly, maximum of 40 minus 52 is actually 0. So maximum of 60 minus 52 is 8. Maximum of 40 minus 52 is 0. We have to compare the option value with the expected value, the discounted expected value. And since here, though we are able to get an intrinsic value, but it's less than the expected value, so we cannot exercise the option yearly. Though it isn't, we have an American option. In this second, here also we cannot expect. So we have to take again 11.95 into a probability plus, and we have to take 0 in downside probability into the discounting factor. We can calculate 7.14. So though it is an American call option calculations, we are unable to exercise yearly. So whether it's a European or American, in this example, both are same. Let's look into a put option. Put option is again the node values are same. So when you are calculating the payoff value, maximum strike price minus the current price 72 is 0. Here 72 minus 48 is 4, and 52 minus 48 is 4, and here and 52 minus 72 is 0, and similarly here 52 minus 32 is 20. So these two nodes for a put option expires in the money. So here is expires out of the money. So you have to have the payoff value. Now again calculate the present value, the expected value. So 0 into the upside probability 62.82 plus 4 into the downside probability, then multiplied by the discounting factor. Similarly here calculate and 4 into upside probability, 20 into the downside probability into the discounting factor. Now you calculate the payoff value for a put option, which is nothing but maximum of the strike price is 52 minus 60, it is 0. Here 52 minus 40 is 12. Now here you can compare, here it is not optimal to exercise. the present value is more than the 0. Here look at it here, 12 is greater than 9.46. So the expected value is lower than the actual put option exercise value. So you can exercise early here. And again, you have to travel backwards. Actually, 1.41 into up probability into 12 into downside probability into the discounting factor. So only difference here, whenever we have and we have the option value which is greater than the present value, the expected value, you have to consider that and for calculating the option pricing. That is only difference. So hope it is very clear. So in the call option, we are unable to exercise early in the node 1 year period. In the put option in one of the nodes, we are able to exercise early, and the put option price for American put option is different. In the next video, we will examine how to calculate a 3-period European and American call option and a put option using a binomial option pricing model. Okay. Thank you very much for watching this. Okay.